Hello there, ladies and gentlemen, and welcome to another video. Now in this one I'll be showing you a little bit of something what I've been working on. So basically here we have a Python program. This is just a shortcut to start it. And what it does is it keeps an eye on the CPU temperature, and once the CPU temperature gets too high it can do something. So it can do whatever you want really, but in this case what it'll do is it'll send a request to my Raspberry Pi server, which will in turn turn on some fans. So the fans are controlled by a basically 433 megahertz remote kind of signal thing. So yeah, I'll probably do a video later on the Raspberry Pi and all that kind of thing alone, but for now you just kind of need a bit of background to know what is happening. So yeah, this is the Python program here. It monitors everything here. It runs in its in a CMD console. Since this is like quite lightweight, you don't need to load any UI libraries or anything like that, and it looks nice as well. There's no like flickering or anything like that. So at the moment I've set the trigger temperature to 45. So when this reaches 45 degrees, what will happen is this here should turn on. Now what this is just a web application that polls the Raspberry Pi server for the status. So this is basically a kind of remote that I converted into digital basically. So yeah, I'll show you what this does. So if I just put on my cam, and if I turn on the first one here, as you can see in the camera you should see that a light came on. So if I turn it off you can see that. So yeah, that's what that does, and the state of this thing is like kept on the Raspberry Pi. So if you refresh the page or whatever, it'll still be there. So this way, if you have any other kind of like programs, such as this here, that sends any requests to the Raspberry Pi to turn any of these kind of like switches on, it will show up here. So keep an eye on that while that's running. So at the moment the highest temperature is 38 degrees, and to increase that we can do a simulation. So well, not really, just kind of like run random code to increase CPU usage, which will in turn increase CPU temperature. So yeah, you might be wondering why are you using TeamViewer? This because we're going to be running the CPU at like pretty much 100%, and I didn't want to run this on my kind of on the machine that I'm using to record all this, because the recording might die if like there's not enough resources to record it, you know. So this way it's a little bit safer. So yeah. So what will happen after you reach 45 degrees is there'll be a 5-second warm-up. So if the temperature stays above 45 degrees for 5 seconds, then this will trigger the request, and you should see that this here should turn to on. Now why I have the warm-up here is because I found that the CPU temperature, or whatever temperature, this is actually taking the highest temperature of everything. So either like the CPU or the GPU, so pretty much everything. So yeah, sometimes like this can jump up to say like 70 degrees for like a second and then jump back down to 40 or whatever. So before, without the warm-up, that would trigger the fans turning on straight away, and so that would not be great. So and then the cooldown here is basically after the CPU temperature drops below 45 degrees, it will wait for 10 seconds before actually turning off the fans. And then the resend here is just to resend the same command. So to turn on command, this is actually a timer, so after like every 10 seconds it'll resend the command. This I put in, this is just in case if like someone else or some other program turns this off, then this will just like keep on turning it on if the CPU temperature is still high. So yeah, I suppose we'll get started. So yeah, keep an eye on this, and keep an eye on this, and I'll start running the load. So as you can see here, the load should jump up here, and the temperature should reach 45 degrees fairly soon. And there you go, it reached 53, and you can see the warm-up is counting up. And there you go, it turned on here. So the warm-up, it turns on at 5. So you can set these parameters in the timer, and as you can see, the triggered is true. And then after this goes to, I believe, 10, it will resend the turn on command again. Yeah, there you go. But obviously this didn't change anything. So if I stop the load, you see the temperature is dropping, and now the cooldown is going up. And once the cooldown hits 10, triggered false, and then you should see in here at the same time this turned off, and then I can see that my fans turned off as well. So let me show you what this warm-up and this cooldown does. So check this out. Alright, so now if I run this simulate thing for a few seconds, so that you'll see the warm-up, it'll like try to warm up, and then just before it finishes the warm-up, I'll shut it down so the temperature decreases, and then it shouldn't trigger the fan. So this will be like, just get that. Come on. This will be like a light load. As you can see here, since the temperature dropped below 45 degrees before warm-up finished, it didn't trigger the fan. And then I'll show you kind of the same thing with the cooldown. So if we wait for the warm-up to reach 5, it'll trigger that. And then if I stop the test here, we should see the cooldown start to increase. And if I start it again, so the temperature reaches, you can see the cooldown reset, and it's still going, so it didn't turn it off again. Then if I stop the load, there you go, the cooldown is starting to count up. And then after it gets to 10, it will turn off the fans here. So if we keep an eye on this, there you go, turn that off. So yeah, that's how that works. So yeah, I'll just go through the code now real quick, or I suppose I'll go through how to set it up as well. I probably won't upload the code like publicly straight away, because there's some stuff I need to tidy up and all that kind of stuff, some stuff I need to fix. But what I'll show you today in the video for like configuring it, that should stay the same. What will change is just like most of or some of the kind of like logic and some stuff like that. So yeah, for this we're actually gonna need to use open hardware monitor lib.dll. So we're gonna be using Python to load this DLL, and this DLL is what gives us all these temperature, all these results basically. So I'll have a link there in the description, or you can just literally Google open hardware, or DuckDuckGo in my case. Just open hardware monitor, and it's the first link. Just click download this zip, extract it, and you'll get like an exe and all that kind of stuff. You can delete all that, just leave this. This system file that actually gets created when you're running the program, so don't worry about that. So if I actually control C this, you'll see like a nice exiting. And you can either stop it like by pressing Control C, or just close this. So yeah, make sure you have the DLL inside the same directory as your monitor.py. And then this shortcut here, if I go into properties, all this is the target is CMD. And what's it doing? It's calling Python. And where's the Python script? The Python script is in this directory here. So if you just press here, copy this, paste it in here, that's pretty much all you need to do. And then advanced and run as admin, because to monitor the, the temperature and some of the other stuff, you would need to run this as admin. So yeah, that's that. So yeah, let's go on to the script itself. Or before that, I'll just quickly show you what simulate load does. So yeah, basically this. If you want to run like every single core that you have, you can do this, or just put in a number. I put in 3 because with 4 cores it was lagging, so yeah, so just see what doesn't like totally lag out your system. This is only for testing anyway. Where this becomes useful is like if you start playing a game or whatever, the fans will then kick on after it reaches that temperature, because I always forget to toggle the fans on like this. So this way it's nice and handy, even if you're not playing a game or whatever. Yeah, it's a weird setup, but I think you could learn from this, since you can apply it to whatever really. So anyway, in the monitor.py script itself, there's a few things that you would want to mess around with. So in particularly under this config, so trigger temperature, that is, let me just make this a little bit bigger. Okay, never mind. Let me actually grab this here. Oops. God damn it, Windows. All right. So yeah, I think I can zoom in here. Oh no, never mind. Okay, whatever, we'll go back here. Actually, font, zoom in. Okay, I'm pretty sure there's an easier way to do this, but whatever, we just did it that way. So yeah, this is in degrees Celsius, so 45 degrees. That was just for testing. For like real use case, I use 80, since my CPU does get quite hot when gaming. It can go up to like 95-ish, so yeah, not great. So this next one is the warm-up period. So after roughly how many seconds do you want the fans to turn on? So like if your CPU temperature has been above 80 degrees for more than 5 seconds in a row, then this will turn on. If you want it to turn on like later or sooner, you can increase it or decrease it, either way. Cooldown time, this is after what amount of time do you want the fan to turn off after it reached below 80 degrees in this case. So I find that 10 is pretty good since it kind of keeps on cooling the computer for a bit. So yeah, it's kind of handy. Otherwise it'll kind of like, you know, jump up and down maybe. Resend on conmax. So this basically, this is after how many seconds-ish do you want to resend the trigger command again, basically. And then the rest of the stuff here, this is just for colors. So like when you run this here, just give it a second. So yeah, you can see the colors here and then here. So yeah, the header, oh yeah, the color text FG, this is all of these here. So the kind of like the values or whatever. Then background is black because that looks best. So if you are using like PowerShell or something like that, instead of a CMD, PowerShell is like by default blue. So this will change the background to black. So the header foreground is blue. So you can see here for each of these. And the header background is black again, so black for everything pretty much. So yeah, the color values, these are like all of these purple things. So yeah, so it's kind of like easier to see the actual values or the actual variables if even. So yeah, space start, this is how much space do you want at the start here. If you don't want any, just get rid of the spaces like so, and it'll be like right above this. So if I just save that, close that, run it again, and the window auto resizes based on how many lines you have and the width of your maximum column. So that actually took me a while to get it done properly, so it's pretty sick. So yeah, as you can see here, now the width is like really small. And then if I increase the width by like a shit ton, so like this, now get out of that, run it again. And there you go. So now there's like a ton of space here. As you can see, it automatically kind of like resized the window based on the size as well. So yeah, it's pretty sick. Yeah. All right, debug mode. I'll just show you what this does. You won't really need it unless you're messing around with the project. But if I turn on that to true and just run that. Alright. Yeah, kind of messed up at the moment, but we can just resize it here. And so yeah, you can see that it displays some stats at the bottom. So this is like the same as it was before because this is handy to see. And then it displays every single, so if I just stop it there. So yeah, it displays like every single output from the sensors, because by like right now to actually show them, I'm not really using like a lot of the different things here, but you can use them for whatever you want. So yeah, I'll just change that back to false. All right, so next is, this will probably change in the proper, so when I actually release the code. So yeah, this is the automatic resizing. So if you don't want to do that, you could just set false for both of these. And it won't like resize automatically. So yeah. Or oh yeah, because by default these are more for kind of like the a startup. So like, you know, the logo, so the logo looks nice, you know, or whatever, not really the logo, but whatever the startup text I put there. So this just looks nice in this kind of resolution, but it also works fairly well here. But as you can see, like there's a space here, and then there's no space after this B. So yeah, so if I put this back to true, and then I ran it again, so as you can see here, formats it better. So the rows are limited, so there's no like space at the end, and there's a small bit of space at the end here as well. So yeah. Okay, so yeah, that's kind of it really. You won't really want to change any of these. So just these if you wanted to, but I don't really recommend it. So yeah, what we're actually doing is we are opening this DLL using the CLR, and the CLR is the Python .NET kind of framework thingy. So yeah, that's kind of like your handler, and then to read it, you basically go through this one. So, and then for each sensor, just kind of update it and then parse the sensor. So yeah, that's kind of that. So you can see that there's like, I needed to put in like kind of my own units or whatever, since it doesn't really come with them, you know. And if you're using a AMD GPU, you would have to add in your own stuff in this get unit of measurement function. Yeah, don't mind this. All this is just making sure that the output looks good. So yeah, populate arrays. This is where the actual sensor data is gotten from, or like stored. So if I just scroll up to the top, I'm storing like different things inside here. So all the CPU temperatures. So if I just run this again for reference, I just put it over here. So yeah, like all this stuff related to the CPU is going in its own kind of array. All the stuff related to the GPU going in its own, the hard drives going its own, the RAM in its own, and then the stats is later on. So yeah. And then, so yeah, all this is still like dealing with the formatting this to look nicely. And display stats, this is actually the function that draws all of this. So I'm just looping through each array and then just doing a bit of formatting here. And then here's the auto with console code and all that kind of stuff. And then the toggle fan. So this is actually where you would put your code that you want to do something when the trigger gets hit. So in my case, I just called it toggle fan, but I'll probably rename this later on to something more useful. So yeah, as you can see, all I'm doing is I'm making a post request to this address here, and I'm just setting data and button 2. So button 2 here, button 1, button 2, button 3, button 4, button 5. So very straightforward. Yeah, and then if like it fails to send, just kind of ignore it, because it's gonna try to send again later on. So yeah, just reset the send counter or whatever. So yeah, exit handler, this is when you press Ctrl+C, it just shows like a nice output, and it stops the program from running. So this is the main while loop where it's all executed. So as you can see here, oh crap, the toggle fan function is called here, based on just a bunch of conditions that I kind of sort of already explained, but this it visualized in code, I suppose. So yeah, and then just to reset the cursor, I'm using this cursor position thingy. So this is from the Colorama. It's the same library that does the colors, and it also allows you to control the cursor so you can set a position. So after it draws everything, it resets its position back to the start and then just draws everything again. So yeah, instead of doing that, let's see here, where was it? Oh yeah. So instead of doing this, another way, instead of like using the cursor, another way is to do os.system and CLS. So this is basically running the CLS screen, but watch what happens if I run this now. Like, it'll still work, but as you can see, it's flickering. This is because it like takes some time to actually clear, like to call this command and then draw the stuff after. So you'll see like a little bit of flickering. So yeah, with the cursor position, setting it to back to this position, the first position, is a lot easier to do for for Windows. Essentially, instead of like clearing the whole thing, it'll just reset the cursor. And there's a lot of formatting going on here, so I'll show you what I mean. If I delete all this, close that, and if I go up into where is it? Yeah, here. So this is adding padding. So, oops. So instead of a space, if I put in like a hashtag, you'll see what this padding actually does. So yeah, give it a sec. Or I messed up a little bit. Well, we'll sort it out. Yeah, all right. So yeah, what the padding does, it just fills in the extra space here so that there is no, so that when you redraw this, there is no, what you call it, there's no kind of overlap. So for example, if I simply don't return anything for the padding, so if I just return an empty kind of thing, let me just close this, and if I start it up again, what you will notice is that you'll get some weird stuff here. So as you can see here, the screen isn't like being properly cleared up, so there's like a lot of duplicate kind of stuff, and the output just looks messy. But if we were using the CLS here instead of this, and if I just restart that, I just kind of increase this a little bit because the padding kind of plays a role in calculating the width and how to resize the CMD window. So yeah, as you can see, now it looks okay. So there's no kind of overlap with everything, but it's still flickering. So that's kind of the price you need to pay if you want a smooth output. you need to do like a lot of padding. If you don't really care about smooth output, don't bother with the padding and just use this. It's a lot easier to do, because like a good chunk of code in here is just like for generating the padding and all that kind of good stuff here. So yeah, thanks for watching, and bye bye.